Hello guys, we are back for quadratic functions again, roots and graph. This is part 2 and I hope you have already watched part 1 of this video. Okay, let's continue. Roots. Y is equal to ax squared plus bx plus c. This is the general format for a quadratic function. And I told you that a must be always a non-zero coefficient. If I put this equation equal to 0, I will get maximum two distinguished roots, x1 and x2. Roots are the points at which the parabola will meet the x-axis, will cross the x-axis. How to find x1 and x2? This is the general approach. X is equal to negative b over 2a plus and minus a square root of delta over 2a. Delta is determinant, b squared minus 4ac. It's a very important factor for finding the roots. Okay, you remember every parabola must have a vertex. And if you draw a vertical line here, this is the axis of symmetry on which you can fold the parabola and left and right side of this parabola will overlap. Okay, the x component of this vertical line when it passed through the x-axis will be exactly negative b over 2a. So the distance from this point to each root, left and right, will be square root of delta over 2a. To have a better understanding of delta, let's look at this graph. Here you see square root of delta over 2a, as I told you, is the distance between each root and the axis of symmetry. Suppose that delta approaches 0. If it goes to 0, the second term will be disappeared. So the roots are joining together and we will have just one single root, which is named double root. What if delta is negative? Let's get more idea. Here, if I have two real roots, as you see, they are separated and generally I expect delta to be positive, and so I have a root of negative b over 2a plus square root of delta over 2a and the other with the minus sign. Of course, the roots could be both negative, both positive, or one of them negative, one of them positive. Also, you know that depending on the sign of a, it could be concave down or concave up. Anyway, when we have one double root, I told you, the roots join together and then the parabola just touch the x-axis at one point and the vertex is exactly on x-axis. Anyway, it could be also positive or negative. So it could be negative, positive, concave up, or concave down. But what if delta is negative? When the delta is negative, we say we have imaginary roots. It's out of discussion here, and so I won't mention complex numbers. We will learn it in another video. Okay, so when we have imaginary roots, sometimes we say we don't have any real roots. So there is no meeting point with the parabola and the x-axis. It could be, of course, concave up or concave down. Look at this example. Draw the parabola with the rule of y is equal to 2x squared minus 3x plus 1. You remember it was c, the constant value, and this is b, negative 3, and this is a. I will start with c, then b, then a. CBA. Okay. C was the vertical intercept, y-intercept. When the parabola crossed the vertical axis, it's positive. What about the b? B was the slope of parabola when it crossed the y-axis. As it is negative 3, it will cross the vertical axis when it's descending. You see it's going down. What about the a? A was the concavity. As it is positive, so it's opening up or concave up. What about the roots? Existence of roots is tightly dependent to delta, to determinant. Delta was b squared minus 4ac. So I will substitute the values. b is negative 3 to the power of 2. Even you can forget about the sign here because even negative 3 or positive 3 will raise to the power of 2, so it's positive. 4 times a is 2, and times c is 1. Delta is positive, is 1. So we have necessarily two separate roots. Okay, let's draw the graph. It's something like that. At the beginning, when I look at the C, I see that it's positive, so it must pass through y equals 1, then descending, because of the B, and then concave up. It has two different separated roots, x1 and x2. Let's draw this one. Y is equal to 2x squared plus 3x plus 1. Okay, I start with C. C is positive, so it's positive 1 again. But here B is positive. So when the graph crosses the y-axis, it's ascending, going up, positive slope. The A indicates positive value, so it must be concave up or opening up. What about the roots? I should check the determinants. Delta is b squared minus 4ac. b is 3 to the power of 2 minus 4 times a, which is 2, times c, which is 1. Okay, still delta is positive, so I must have two separate roots, real roots. I start to plot the graph. Here I have y versus x. First I check the vertical intercept. It's positive 1 actually, and then ascending here because b is positive, and then concave up. It must cross the x-axis in 2 points, x1 and x2. The other one, y is equal to negative 2x squared plus 3x minus 4. As you see, I start from the last coefficient, negative 4, c. It's negative, so when it crosses the vertical axis, it will be a negative 4. The b is positive, so when it crosses the vertical axis, it must be ascending, positive slope. And a is negative, so the parabola will be concave down or opening down. What about the roots? I should check the determinant. Delta was b squared minus 4ac. b is 3 to the power of 2 minus 4 times a, which is negative 2, times c, negative 4. Okay, delta is negative, you see. So there is no real root for this parabola as I see. Okay, no roots, and so I start to plot it. First I start from negative 4, which is the y-intercept, then ascending, and then I draw the parabola with no touch or any crossing point with x-axis. Draw the parabola with the rule of 2x squared minus 3x plus 4. Let's check this one. Plus 4 indicates a positive vertical intercept. Negative 3 indicates the negative slope of the graph when it crosses the vertical axis, so it's going down, negative slope. And a has a positive sign, so it must be concave up or opening up. What about the roots? I check the delta again. The determinant is b squared minus 4ac. b squared is negative 3 squared minus 4 times a is 2, times c is 4. Yes, here delta is negative. So there is no root again, no real root. I start plotting the graph. I start from positive 4, decreasing with negative slope, and then I draw the parabola with no touch or any crossing point with the x-axis. Find the axis of symmetry of the following parabola. Y is equal to 2x squared minus 8x plus 6, and draw the graph. Okay, I told you axis of symmetry will have the x value of negative b over 2a. b is negative 8 here. I substitute in numerator, and then for denominator I have 2 times a. a is 2 here. The answer is 2. So in coordinate system I should put the vertical line of symmetry here exactly when it passes through x equals 2. How to draw the graph? It's very easy. You remember the approach was CBA. I start from C. C is the vertical intercept. It's positive, so it's positive 6. And -8 indicates the parabola will go down when it crosses the vertical axis. It's something like this, descending here. And about 2, a is positive, so it will be concave up, opening up. But what about the roots? Should I draw it like this, or draw it like this, or draw it like this? I don't know. It depends on the number of roots. So let's check the roots. Here, determinant is very important. Determinant was delta is equal to b squared minus 4ac. b is -8, so -8 to the power of 2. As it's not that important, I'm raising that to the power of 2, so it could be also 8 to the power of 2. -4 times 2. 2 is a, and c is 6 here. It seems that delta is positive, so I must have 2 separated roots. So I should draw the parabola something like this. It have 2 crossing points with the x-axis, the roots. More than that, pay attention to the axis of symmetry. It's very important. Here, from 6 to the axis of symmetry, I have 2 units distance. It's 2. Then I continue for again 2 units more, and then I see another point here on the right side as it's symmetrical. So if I go down, it will be at the point x equals 4. This is the general property of the axis of symmetry, you know. Find the vertex of the following parabola. Y is equal to -x squared plus 2x minus 1. And draw the graph. Okay, you remember that anyway, when the parabola is drawn like this, y opening down because a is negative, it has a vertex here, maybe. Here I know that the x component of this vertex will be -b over 2a, and if I put this value into this equation, I will get the y value. This is the general approach. Okay, let's do that. Here first I go for x. X is a minus b over 2a, b is positive 2, a is -1, so I substitute the values and the answer is 1. Seems that here is the axis of symmetry, y versus x. I think it's 1 maybe, and it's 2. This is the axis of symmetry. And so the parabola may be here, maybe here, and maybe here, depending on the number of roots. I don't know. I should check the value. One easy approach is substituting this value in the equation. So the y value for the vertex will be -x squared, this one, and then plus 2 times 1 minus 1. Okay, here I have -1 plus 2 minus 1. The answer is 0. So seems that y value is 0. So I think the parabola will have a vertical line of symmetry here at x equals 1, and then the parabola will be here exactly. The vertex is exactly on x-axis because the x value is 1 and the y value is 0. So we must have just a single double root. Okay, single double root. You pay attention, the roots join together, and so we have just one root. Let's check the determinant again. You remember delta was b squared minus 4ac on the other hand. So b squared will be 2 to the power of 2, b is 2, -4 times a is -1, and c also is -1. As you see, delta is 0. It's also confirming that we have a double root. So the two roots are joining together at this point. Let's draw the graph. For drawing, I start from C, then I will go for B, then for A, CBA. -1 indicates the graph will start from the y-intercept of -1 here. B is positive, so when it crosses the y-axis, it will be ascending, and it's concave down, something like that. And the vertex is exactly here, as I told you. One interesting property of the vertical line of symmetry, axis of symmetry, is that from here to here will be equal to from here to here, as you see. So here I can measure the value to be 1, and also it's 1, the corresponding point again on the body of the graph. Generally, if I select any point here, and if I draw a normal line to the axis of symmetry, and I continue for the same length, xx, I will find the corresponding value or corresponding point on the body of the graph, always. Find the roots of the following parabola, y equals x squared minus 4x plus 3, and draw the graph. For the roots, we have the general approach of x equals negative b plus or minus square root of determinant over 2a. You remember determinant was b squared minus 4ac. b here is negative 4 to the power of 2 minus 4 times a. a is the coefficient of x squared, it's 1 times 3. 3 is the c. So it's 16 minus 12. I substitute the values here. And as you see, the square root of 4 will be 2. So the answer will be negative 4 plus or minus 2 over 2. The answer will be 1 and also 3. We have two separate distinguished roots. On the coordinate system, 1, 2, 3, these are the roots where the parabola will cross the x-axis. Okay, how to draw the graph? Here, again, I start from the approach of CBA. CBA. Let's concentrate on C. As you see, here C is 3, so the graph will cross the vertical axis exactly at the point y equals 3. Then I concentrate on negative 4, which is the B. As it is negative, the graph will cross the y-axis when it's descending. And then I draw a parabola with concave up shape. Why? Because the coefficient of x squared is positive. So it's something like that. It's finished, but let's get more information from this graph. As you see, here is the line of symmetry, and it's at the same distance to the roots. 1 here and 1 here. It must be. More than that, this is the vertex, and as you see, vertex has the x component of 2. How to find the y component of the vertex? It's very easy. Just put the 2 in the equation. So y must be x squared, which is 2 to the power of 2, minus 4 times 2 plus 3. That's all. So it seems to be negative 1. So the vertex has the coordinates of, let me write it, vertex has the coordinates of x equals 2 and y equals negative 1. That's all. Domain and range of quadratic function. Generally, domain is referred to permitted x values for every function, and range is referred to permitted y values. For every type of quadratic function, x values are supposed to be from negative infinity to positive infinity. Generally, we do not expect any restriction for x, regardless of if it is concave up or concave down. So the range is always minus infinity to plus infinity. That's all. But for the y values, pay attention. If it is concave down like this, here a maximum value for y, maximum permitted value for y is here, y max. It's the y value for the maximum point. So the range will be from here and smaller to down. If it is concave up, let's name it y min. So the permitted values for y will be from y min and greater. So for the concave down, I say the range is y is smaller or equal to y max. Here y is greater or equal to y min. This is the range. Find the range of the following quadratic function. Y is equal to 5x squared minus 20x minus 1. It's a concave up parabola. Consider a coordinate system like this. As you see, x has a positive coefficient, so it must be concave up. Here I see the constant value is -1, so y-intercept is here, -1. And then as it's -20, the coefficient of x, so b is negative. When b is negative, the function when crosses the y-axis will go down. It has negative slope. It may be something like this, okay? Here we will have a vertex as the x value is -b/2a, and after we find this value, we put it in the equation and then we find the y value. It's necessarily y minimum. So the range will be something like that. Y is greater or equal to y minimum. This is the approach. Let's start finding that. So just keep it in mind that the format of the function, the parabola may be something like this. The appearance may be something like this. Okay, I start from finding the x value for the vertex. -b/2a. b is -20. I substitute the values. 20/10 will be 2. So, okay, the value is 2. X value is 2. The next step is this. I should put the 2 in this equation. And then we will find the y here. Okay, if I substitute the 2 in this equation, 5 times x squared will be 5 times 2 to the power of 2 minus 20 times x, which is 2 again, minus 1. The answer is -21. Yeah. So y will be -21. The permitted values for y will be from -21 and more. So the range will be y greater or equal to -21. At last, I am grateful to you because of watching this video. Take care. See you in the other videos.